Today's lesson is 10-7, comparing populations. So you're going to be looking at a poll or some sort of survey or some sort of analyzation of something between two different populations on the same topic. So when you're doing this, you are going to use the mean and you're going to use the mean and the mean absolute deviation, the MAD. So the mean and the MAD when you're using a dot plot to compare your populations. Normally, the mean and the MAD is used when there isn't a lot of variability, um, or when the distributions look about the same in terms of shape and center. You'll use the IQR and the median to describe skewed distributions. Skewed meaning they all go to one side or the other of your data set. So there's a lot more variability in your data. Okay, so we're going to start by looking at the dot plot. And in this dot plot, you are going to look at your mean, use your mean and your MAD to compare. Okay, so this is a double dot plot that shows the time that each candidate in a debate spent answering questions. Okay, so they looked at 15 questions and they timed the candidates, like in a debate, how long it took them to answer the question. So whenever you have a dot plot, you are going to look at that mean and you're going to have to calculate that mean and then the MAD. So the mean of this dot plot, the mean for candidate A is 84. That's your balance point. Okay, that's why we use that little triangle. That's what I talked to you guys about yesterday. Mean is a balance point. And then the MAD for candidate A is 16. So now we're going to look at candidate B. Candidate B has a MAD of 16 as well and a mean of 58. Okay, so using that data, you need to go back to the context of the problem, the time it takes for a candidate to answer a question, and you need to draw a conclusion or write a sentence about that, backing it up with your data. So in this situation, I would say that the variation in the times was about the same, but candidate A has a greater mean time, right? The variation is both 16. The MAD is your variation. It's both 16, so they vary about equally. But if you look at candidate A, they have an 84-second mean time, and candidate B has only a 58-second mean time. So on average, candidate B answers the questions quicker than candidate A. Okay, that's what we know from our data. So now you have to write a sentence talking about that. So I would say that candidate A took an overall longer time to answer his questions than candidate B compared to the means. Candidate A's average time, I'm going to scroll this up so you can see it all. Candidate A's average time was 84 seconds compared to candidate B's, who took an average of 58 seconds. Okay? So you can safely say that candidate A took an overall longer time to answer their questions. He took longer in time. Now, why did he take longer? I don't know. He took longer because maybe because he didn't know the topics, or he didn't know the information, or he needed longer to formulate his answer. Candidate B maybe just said the first thing that came into his head. I don't know. I can't answer that without seeing the actual video, but we can safely say that candidate A took a longer time to answer questions than candidate B. That based on their means. Now, you could, if you wanted to, and you don't have to do this, but this is a way that you could also express it, your difference, in terms of your measure of center, as a multiple measure of the variations, which means you look at the mean, compare the means, and then divide it by the MAD. So your mean for candidate A minus your mean for candidate B is 26, and your MAD is 16, so you would divide 26 divided by 16 and you get 1.6. So you could say that the mean the difference in the means is about 1.6 times the MAD. Okay, now that would really only work if you have an equal MAD. So if your MAD is the same for two data sets, you could subtract your means and then divide it by your MAD, and that'll tell you how many more times the means are compared to the MAD. But it's not something that you have to do. This in itself, this sentence right here is an excellent answer. It's an exceptional answer. So if you would write your sentences like this, you would be exactly where we want you to be. Okay. So here's another example. We're going to skip A and we're going to go down to B. So here's another example. So you have a double box and whiskers plot that shows the medians of 100 random samples of 10 speeding tickets for each state. You're going to compare the variability of the sample means to the variability of the sample costs. So when you're looking at a box plot, you have to use the median in the IQR to draw your conclusions and compare your data. Okay? So you have to find your median and you have to determine or calculate your IQR. So in state A, the IQR is 10 and the mean is 65. Or median, sorry, is 65. And in state B, the IQR is 10 and the median is 80. 80 is 80. Okay, so now you have to make a conclusion about that data. Now this is about speeding tickets and the cost of speeding tickets in two states, state A and state B. So the middle, if you look at this, this is a really interesting data set. That's why I chose to show it to you. If you look at this, each one of these sections is 25%. So from the whisker to the Q1 is 25, from the Q1 to the median is 25, and from the median to the Q3 is 25. So right here, 25, right here, 25% of your data, right here, 25% of your data. So 75% of your data in state A lies lower than not even 25% of your data in state B, because state B's 25% marker is right here at Q1. So 75% of the ticket costs in state A cost less than not even 25% of the ticket costs in state B. That's huge, enormously huge. The IQR is the same, the data is all scrunched up, but state B's data scrunched up at a higher cost than state A's. So that essentially means if you're going to speed and get caught, you want to do it in state A because it's going to cost you, chances are, a lot less than it is in state B. So your conclusion could be that state A's speeding ticket cost, I'm just going to get it all done and then I'll read it. Okay. State A's speeding ticket cost is less than State B's given the data. 75% of the data in State A is less than 75 of the data in State B's data. So, and you could write if you wanted to. So to conclude, if you're going to speed, you should speed in State A, where it's going to cost you less than in State B. That would be my conclusion. That this is huge. This is a big difference. So if you're going to speed, I'd speed in state A than state B. Okay, so now for what you have to do. Today, for your practice problems, you need to calculate okay, so you're going to do number 4 and number 5. Number 4, and this is on page 452, number 4 compares two sets of data, Team A and Team B, goals scored by two different hockey teams in a 20-game season. So you're going to, and these are in a box plot. So in a box plot, you have to calculate the median and the IQR, and then you need to draw a conclusion, a sentence, write a sentence about it, concluding it, okay? Then in number 5, you have a dot plot that shows the test scores for two classes taught by the same teacher. Okay, so here you have class A and class B, and these are your test scores. So you need to calculate the mean and the MAD, and then you need to compare them and write me a sentence comparing them. Now B in each one B, let me get to my marker here. B here in this one asks you to express the difference of measures of center as a multiple of the measure of variation. You don't have to do that. And for this one, 2B asks you to do the same thing. You don't have to do that. I'm going to give you the answer to it. If you want to try it, that would be great. Um, if you're in my accelerated, I would like you to try that. But it is not something that you necessarily have to do in order to draw this comparison. But if you can try to do that, I'd like to see if you get that right, and I would challenge you to be able to do that. It's just it's a extension, and it's not something that you have to do, but it's something that I would like you to try to do to compare. Okay? Okay.